Good afternoon to you, Mark Sudduth, HurricaneTrack.com, here with your Hurricane Outlook and discussion for Tuesday, September 29th, 2015. A lot going on to talk about here, mainly having to do with Tropical Storm Joaquin in the southwest Atlantic Basin. The very latest satellite picture of it you can see here in the visible loop. It looks like it's trying to get better organized. Still has that sort of rounded edge appearance due to northerly and northwesterly shear. But recon is flying out here, and we are seeing reports of lowering pressures and increasing wind speeds. The water temperatures over the region where Joaquin is located currently, very, very warm, high ocean heat content, and that means a lot of high octane, deep, warm water available for this storm to take advantage of that has not been churned up by other hurricanes this season. A lot of available energy, and that even extends on up. Even though the TCHP values are lower, you can see that the edge of the appreciable amounts of upper ocean heat content do extend up to just off the mid-Atlantic states, and that might come into play over the next few days. So let's take a look at what we do know, and then we're going to talk about what we don't know, because I think it's important to sort of admit where you don't know what's going to happen. So first of all, what we do know, the forecast track, a pretty decent cone of uncertainty here. You remember recently it was on up into New York and parts of the mid-Atlantic states, but now it's a little bit smaller in terms of how far out it goes longitudinally, north or south, because it seems to have been moving a little bit slower, and then there's also a very large spread of guidance associated with it. So this is just a sort of middle-of-the-road rough idea of what could happen with it over the next few days. I believe very strongly we're going to see these S's change to H's, and that Joaquin will become the season's third hurricane before all is said and done. So looking back at the satellite image here, I want to zoom in on it. Again, you can see this sort of rounded, very fine edge to the thunderstorm complex, the attempting to develop central dense overcast, and it's understandable why that's the case. You can see it also here. This rounded edge, instead of everything fanning out in all directions in a clockwise manner, you can tell that there are strong winds coming down from the north and northwest, shearing the tops or pushing those thunderstorm tops away. And you can tell even further by the analysis here from the upper air winds from the University of Wisconsin site. Here's this nice anticyclone developing over the western Atlantic. The lightest winds are over here, but even where Joaquin is located, decent outflow definitely on the south and west side, and some trying to establish outflow on the north side, but it is restricted at the moment due to those strong northerly winds, as you can clearly see here, coming southward around the top of this upper ridge. But as Joaquin moves further to the west and south of west, it should get into a lighter shear environment. This upper ridge is likely to expand outward a little bit more, and those 200 millibar winds way up in the atmosphere will relax, and it's not going to take much to allow this to become a hurricane. So let me get rid of some of these other graphics to make room on my board here for what I want to show you. So the latest model plots, I want to give you a look at the suite of what we call the spaghetti plots, is what it's commonly called. This is the very latest 1800 or 18 UTC, and the current intensity, I think, is up to 55 knots. And so I believe we're going to see, and that's 65 miles per hour. So I think at the 5 p.m. advisory, remember there's recon out there flying as I speak, and they're detecting some pretty strong surface winds and a lowering of the pressure. There's a couple of things I want to show you here. Certainly, we have a pretty good spread in the model envelope overall, no doubt about it. But look at a couple of these important ones in here. The TVCA and the AEMI. That's right in here. This line here that I'm drawing on with red. That's the ensemble mean, or the average of the GFS ensembles, which I'm going to show you in just a minute. That's very important as I discuss what's happening here. And you can see some of the other models, the simpler BAMs. Then, of course, you have the H-Wharf model, which comes into the mid-Atlantic states, the Carolinas, perhaps, maybe, I say the Carolinas, more like North Carolina, Southeast Virginia. And the H-Wharf is the Hurricane Weather Research Forecast Model. And then you have the GFDL, and the AVNI, which is basically the GFS operational. Bottom line, with all that I'm saying, we have a pretty significant spread in the models, but I'm going to show you, to me, what's very telling about this and why this still poses a significant threat to the Carolina coast here and on up towards possibly Long Island and maybe parts of southern New England. So let's start looking at the GFS. This is the 500 millibar layer of the atmosphere, about 18,000 feet up. A pretty good representation of the steering layer. Some people use 700 millibars. I like to look at the 500 millibar level. That shows me the troughs and the ridges of pressure, kind of like a topographic map of the atmosphere, the best in my opinion. So this is 24 hours from this morning. So this is valid Wednesday morning, 12 UTC, or 8 a.m. tomorrow morning. Here is the storm. Here's Joaquin. This energy over here, very lightly reflected in the model, is the leftovers of Ida. And then here's the lowering of the heights in the atmosphere, this trough trying to dig in over the southeast United States. 48 hours out into time. You see Joaquin coming in close to the central Bahamas here, and I have to emphasize at this point, interests in the Bahamas clearly need to pay attention to this. A lot of talk about what's going to happen along the U.S. East Coast, rightfully so, with tens of millions of people potentially in the path of this system. But the Bahamas, we don't want to forget about folks down there. You could have an intensifying hurricane within tens of miles of the central Bahamas by Wednesday night or Thursday. So that's important to note. Also, you see the dip in the height lines here. This is the important trough that's trying to carve out over the eastern United States that would eventually perhaps create a cutoff low that would normally easily pinwheel the system right into the mid-Atlantic states, because over the western Atlantic you do have this ridge sitting out here, and this very warm water has allowed this ridge to be pretty strong. So as we go to the 72-hour map, look what happens. There's the cutoff low sitting over Georgia and the western Carolinas, Alabama, Tennessee. There's Joaquin represented in the 500 millibar field. Here's the ridge, very strong. As this digs in, this has an equal and opposite reaction to strengthen, and you say, well, this looks pretty obvious. It's just going to follow the stream flow right on up into the mid-Atlantic states. Somebody here from the Carolina Outer Banks northward to New Jersey's north coast up to maybe Manhattan are going to get smacked. But hey, not so fast, because look what happens. And here's where it just gets bizarre to me, and other meteorologists that are out there as well. I'm not a meteorologist. I'm a geographer by degree. I studied climatology, geographic impacts of hurricanes, and certainly meteorology courses, but I'm not a certified meteorologist, and I think that's a big distinction here, that I can look at this perhaps with a different set of eyes, as not necessarily trying to figure out the physics, but just understanding the face value of what these maps mean, looking at them from a logical perspective, and what I know about how the atmosphere works, it doesn't make sense to me. And here's what I'm talking about. Here's our cutoff low clearly over the southeast United States. But what on earth is going on over here? You know, is this the remnants of Ida? It's like it's trying to bleed off some of this energy out to the east and allow a lowering of the heights out here enough that it's kind of like a marble or a ball rolling downhill. So instead of coming around this upper low between it and the ridge here, it creates an escape route for Joaquin off to the east-northeast or even the northeast. And if we go further out into time, this is valid Saturday morning. Here it is Sunday morning. And that's exactly what happens. You have all this weird-looking energy out here. Each of these areas of vorticity, 3 distinct areas, and it just gets captured, and then it just swings it on out into the Atlantic, no problem. And then we have this other kind of nor'easter-looking hybrid system with a ton of rainfall along the mid-Atlantic states, and Joaquin goes harmlessly out to sea. It doesn't make sense. I don't understand. And as I said, I've seen other meteorologists talking about this on Twitter and elsewhere on different message boards and Facebook posts, that it just doesn't make sense. it's like it tries to sort of destroy the storm and create multiple pieces of vorticity or energy and send it out into the Atlantic, no harm, no foul. And I want to show you what that looks like zoomed in here. This is a higher resolution version, and we're looking at this at 69 hours out into time. So this is roughly Friday morning, a couple hours before sunrise. And here it is. Now we're at the 850 millibar level, or about 5,000 feet up. And this shows a spin in the atmosphere, what we call vorticity. And look at Joaquin. Very well represented. I got to slow down here. Very well represented in the model field. Round in its appearance. I look at that and I say, yes, that is a healthy tropical cyclone. I don't see any weird lobes of energy sitting out here. This is the remnants of Ida trying to make a comeback. So I can look at this and I say, all right, that's something that's worth watching, because it could come right up in here and pinwheel into the mid-Atlantic states anywhere in this region. So you say, all right, well, that seems pretty cut and dry. But as I move through the different frames here, watch what happens. This is 72 hours out, if it'll respond for me. Come on, I know you can do it. There's 72 hours, and look, there's the beginnings of what's just weirdness in the model. Here's every 3 hours out into time. This is 75 hours. And then look at what happens at 78 hours and finally at 84 hours. Again, what in God's green earth is that? I have no clue. If it's a well-defined hurricane by this point, and many of the models are suggesting it will be, what the heck is that? Why does it grow some kind of an arm or an appendage of energy off to its east-southeast? That doesn't make any sense whatsoever. Here comes the leftovers of Ida trying to come in. And so do you look at all of this and say, well, that doesn't make sense. I don't see how that can happen. And so you throw the whole thing out? It's hard to say. And just look what happens as I go through time here. That appendage grows stronger. You have all kinds of energy trying to compete with itself. The upper level energy sitting over here over the southeast. And it would normally pinwheel this right into the mid-Atlantic. But energy's trying to escape to the east. It's just a headache. And I tell you, the people at the National Hurricane Center have their work cut out for them. Now, that being said, again, let's take a look at the, I want to show you that last. One more time. This is the ensemble mean average right there. The GFS operational hands it off to the east like this, as does the Euro for the most part. They don't have their maps as highly detailed, publicly available, so I can't show them. But let me show you this. This is the very latest 20-member ensemble group of the GFS. Now, it looks like a mess because it's got the entire Atlantic Basin covered. But look right in here, this clustering of models right into parts of the mid-Atlantic. I mean, more of these hit the east coast of the United States than escape out to sea. And if we look back at the other particular graph here, I want to zoom in. There is your ensemble mean. I'm going to draw yellow right there. That's the average of all of the plots that I just showed you. I think that speaks for itself. We're going to really have to watch this. The ensemble mean isn't out here. And we have all these members of the ensembles out here over the open Atlantic. There it is. You can see it for yourself. Plenty of those members bring it right into the mid-Atlantic states, maybe the North Carolina Outer Banks, some of them farther up the coast towards New England. Needless to say, the next several days are going to be quite interesting. First up, interest in the Bahamas, need to monitor this very closely. And then if you're on the North Carolina Outer Banks to points north, to Cape Cod even, without Joaquin in the picture, it's going to be a very wet and stormy pattern over the next few days. So it's time to pay attention and be ready for what may come your way. So the answers are not easy, that's for sure. We're going to have to watch it and just see what happens and be ready to react accordingly. So, I wish I had more. As I said on my blog today, sometimes you get an easy forecast where the hurricane behaves as expected. The pattern is very simple. Even though it's a bad hurricane like Katrina, that was a fairly easy forecast. It looked like it was going to come around into the Gulf and hit somewhere along the central Gulf Coast, and they just had to refine it, with New Orleans being a serious concern, but the overall forecast wasn't as dicey and iffy as we're looking at with this situation. And East Coast hurricane threats are commonly a big headache. So stay tuned. We'll have to just see what happens. All right? Hopefully that helps you to at least understand the complexities of what's going on. And we'll see what happens each day. That is it from me for today. Thanks for tuning in. If you're watching this on our YouTube channel, be sure to subscribe, and you'll have these updates in your inbox every time I post them. Of course, this is in our app, and I'll be posting these video blogs on all of our social media outlets over the coming days. I am Mark Sudduth for HurricaneTrack.com. Thanks, as always, for tuning in and giving me your time and attention. Hopefully you learned something. I'll be back with more info, hopefully decidedly better than what we have today, for you tomorrow.